and welcome to another video. To show that the product of these two identities is equals to sin alpha cos beta if tan alpha is equals to x cos theta over 1 minus x sin theta and tan beta is equals to x minus sin theta divided by cos theta. What I'll do first is I'm going to first prove that theta is equals to alpha minus beta or 90 degrees, because that's the only way that's the only way to be more easier to solve this problem. All right. Okay, so what I'm going to do first is I'm going to write this again. I'm going to write this expression, the expression for tan alpha and the expression for tan beta, and I will use each expression. From each expression, I'm going to express x in terms of sin theta, cos theta, and tan alpha. That's using the expression for tan alpha. And I'll do the same thing with the second expression, which is that of tan beta. That is to make x the subject of the formula. All right, so we are giving tan alpha to be equals to x cos theta over 1 minus x sin theta. And we are also giving tan beta, which is equals to x minus sin theta over cos theta. So what I'll do from here is, so from tan alpha equals to x cos theta over 1 minus x sin theta. Now I'm going to express x in terms of sin theta, cos theta, and tan alpha. Nice. So in this case, what I'll do from here is to cross multiply. So by cross multiplication, this will be tan alpha times 1. That will be tan alpha. Tan alpha multiplied by negative x sin theta. This will be negative x sin theta tan alpha, which will be equals to, then this is more like having tan alpha over 1. So 1 times x cos theta, that will be x cos theta. So I'm going to carry this over to the right hand side. So this will come here to become plus x sin theta tan alpha. Remember, this is because I want to make x the subject of the formula. So when I carry this over to the other side, I'm going to have tan alpha to be equals to x cos theta plus x sin theta tan alpha. Nice. So now x is common on the right hand side. So which means this will be x by factoring out x will be x, when factored out, it will be x parentheses cos theta plus sin theta tan alpha, and this will be equals to tan alpha. So to make x the subject of the formula, I'll divide both sides by this. Okay, that is cos theta plus sin theta tan alpha, so that x will be equals to tan alpha over cos theta plus sin theta tan alpha. So this is the expression for x in terms of cos theta, sin theta, and tan alpha. So I'm going to call this equation 1. This is equation 1. Okay, so now I'm going to use the expression for tan beta, okay, to write an expression for x in terms of sin theta, cos theta, and tan beta. So which means also from tan beta equals to x minus sin theta divided by cos theta. So I can also what? Express x in terms of sin theta, cos theta, and tan beta. So that this will be, so now from here, I'll cross multiply. So this would be tan beta cos theta will be equals to x minus sin theta. Remember, I want to make x the subject of the formula, so I'll carry this over to the left hand side so that x will be tan beta cos theta plus sin theta. So this is the expression for x in terms of sin theta, cos theta, and tan beta, and this becomes equation 2. Nice. Okay, so what I'm going to do now is, okay, now let me equate the two expressions for x. Okay, let me equate the expressions, okay, the expressions for x. So the first expression is, we have tan alpha over cos theta plus sin theta tan alpha, and that will be equals to tan beta cos theta plus sin theta. Okay, so again, I'm going to cross multiply. So this will multiply this. This is over 1. So 1 times tan alpha, this will be tan alpha, and it will be equals to, now let's expand. Now cos theta multiplied by tan beta, cos theta multiplied by tan beta cos theta. This will be tan squared, no, tan beta cos squared theta. Cos theta multiplied by sin theta. This will be sin theta cos theta. Then plus sin theta multiplied by tan beta cos theta. That will be tan alpha tan beta. Then sin theta, okay, cos theta. Then plus this multiplied by this. This will be sin squared theta, okay, tan alpha. This is the right hand side. Okay, so what I'm going to do now is, okay, now let me carry this guy and this guy over to the left hand side so that we can have tan alpha minus tan alpha tan beta sin theta cos theta, then minus sin squared theta tan alpha. That is when I carry this over to the left hand side, it will be negative, and also this, it will be negative. Then on the right hand side will be tan beta cos squared theta and plus sin theta cos theta. Okay, all right. So now tan alpha, this is common. So this will be tan alpha, open parenthesis, 1 minus tan beta sin theta cos theta minus sin squared theta, and that will be equals to tan beta cos squared theta plus sin theta cos theta. Okay, now, so what I'm going to do now is to, okay, 1 minus sin squared theta, okay, that will be equals to cos squared theta using one of the Pythagorean identity. That is, 1 minus sin squared theta is equals to cos squared theta. So which means that on the left hand side will be tan alpha parenthesis. So when this is cos squared theta, so this will be cos squared theta minus tan beta sin theta cos theta, and that will be equals to tan beta cos squared theta plus sin theta cos theta. Let's not forget that I want to show that theta is equals to alpha minus beta. Then I can use this to prove that the product of these two identities is equals to sin alpha cos beta. That is the only way I understand how to do the question or to solve the question. Okay, so now what I will do next is to divide both sides by cos square theta. Divide both sides by cos square theta. So dividing this by cos square theta, this will be tan. If I now distributing tan alpha into this subtraction, I'll get tan alpha cos square theta. So this will be tan alpha cos square theta divided by cos square theta. That will be tan alpha. Then minus tan alpha tan beta, okay, because multiplying this will be tan alpha tan beta sin theta cos theta divided by cos square theta. So cos, we cancel cos, then we're going to have tan alpha tan beta, then tan theta. Yes, and this will be equals to, dividing this by cos square theta, that will reduce to tan beta. Then dividing this by cos square theta, this will become sin theta divided by cos theta, sin theta cos theta divided by cos square theta. That will be tan theta. So this will be tan theta. Okay, so which means that so what I'll do again from here is to write an expression for, okay, so in this case, this will be tan alpha. So from here we have tan alpha, okay, tan alpha parentheses 1 minus tan beta tan theta to be equals to tan beta plus tan theta, so that tan alpha will be equals to tan beta plus tan alpha, tan beta plus tan theta rather, over 1 minus tan beta multiplied by tan theta. Okay, this makes sense. Okay, so which means, okay, now let's recall one of the formula for tangents. Okay, now if we have tan alpha plus, because from here we have tan beta plus tan alpha. I'm bringing out this will be 1 minus tan beta tan theta. Okay, so which means that tan theta plus beta will be equals to, tan theta plus tan beta divided by 1 minus tan theta multiplied by tan beta. Yes, this is one of the formulas for tangent. That is double angle formula. All right, so which means that from here we have that tan theta plus beta will be equals to tan alpha. Okay, that makes sense. So this guy will cancel this guy, then we'll be left with theta plus beta equals to alpha. So I'll carry this over to the right hand side so that theta will be equals to alpha minus beta. Wow. So, and that's what we have here. Nice. Okay. So now, the next thing to do is to show that the product of these two identities is equals to the product of sin alpha cos beta. So now to show that sine of the sum of theta and beta multiplied by cos of the difference between theta minus alpha, difference between theta and alpha, okay, is equals to sin alpha cos beta. So what I'll do is, for this identity on the left hand side, so I'm going to start with the left hand side. I'm going to use the left hand side. So we have that the left hand side is sine of the left hand side, okay, is sine of the sum of this multiplied by the difference between cos of the difference between theta and alpha. So we have here that theta equals to alpha minus beta. So this will be sine of theta will now be alpha minus beta plus beta. Then cos theta equals to cos theta minus, okay, theta is now alpha minus beta. Yes, alpha minus beta. Then minus alpha. Minus alpha. So in this case, minus beta plus beta, that will be 0. So that this will be sine alpha multiplied by cos alpha minus alpha, that will be 0. Okay, then this will be negative, that's cos negative beta. Okay, now we can now recall one of the statement that says that cosine of a negative angle will be equals to the cosine of that angle. Let me put it that way. There's a way I want to put it, but yes. Now, this is very important. Cosine of a negative angle will be equals to the positive, that is cosine of the positive that's cosine of the positive of that angle. All right, so in this case, this will now be sine alpha cos beta. So therefore, the product of sine theta plus beta cos theta minus alpha, okay, is equals to sine alpha cos beta. And this is how to show that the product of these two identities is equals to the product of sine alpha cos beta. And with that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.